Okay, so here's part 2, page 3. So in order for you to actually find the regression, so the page before is when we give you the regression equation, the different things that you would need to do with it. This is now the steps to actually find the regression using your calculator. So it's stat, edit, inputting your information in L1, L2. I feel like we might have done this before in one of those calculator sheets, but I'm not 100% sure. And then stat, calc, and depending on your operating system, it might be a little bit different, but I think most of you have the updated operating system now, so these should all work. So let's go through and find the regression line here for a medical application. So we have cigarette consumption and lung cancer. So here's the cigarette consumption in 1930 per person in these different countries: Sweden, the Netherlands, Finland, and England. The lung cancer deaths in 1950, so 20 years later, per 100,000 males. How many of them died of lung cancer. So obviously, as you would assume, the more cigarette consumption had the greater number of deaths of lung cancer. Use a graphing calculator to first create the scatter plot and then find and graph the regression line. So let's go through first. The scatter plot is probably the easier. Well, let's start with stat edit and let's go there. So let's follow our steps. So step 1 says stat edit. So I go to stat and I choose edit, so I hit enter. And then I'm going to create these. I'm going to clear out my list, and do not delete your list because then you're in trouble. So when you go to clear out your list, go up to L1, make sure it's highlighted, hit clear, enter, don't hit delete because then the whole list is gone. Arrow over again, go all the way up to the top for list 2, clear, enter, and then it'll clear out your list. If your lists are gone, if you don't have list 1 and list 2, go to stat and go down to number 5, which is setup editor, and it should reset the lists for you. Okay, so back here, list 1. Let's put in our X values. And in list 2, we'll put in our Y values. And then we're going to go through our steps. So now I've inputted it, so I go to quit, and then I go to stat calc again. And now I'm going to calculate, and now in this question I'm just following my steps up here. Choose the preferred regression. I want to do a linear regression for this one, but I could do any kind of regression. I could do a quadratic, a cubic, a quartic, and see which one fits it better, because maybe the data is actually quadratic or parabolic in shape, or maybe it's cubic with a squiggle, okay, or quartic or something else. We've got natural logs and stuff down here, okay? So for now, though, we want to try a linear regression. So hit enter. And this is, again, with the new operating system will come up like this. So we definitely want list 1 and list 2 there, okay? And I can arrow down. In this case, I want to do store regression equation. And the place I want to store it, I have to go to variables, which is vars. So I'm going to press vars. And when I press vars, I'm going to go under y vars, which are my y variables. And I'm going to hit enter for function, and I'm going to choose it as y1. So what I've done now is I've stored that regression equation as my y1 equation. Okay? And that is it. Now I go down to calculate, I hit enter, and then it says done, and it gives me my linear regression equation. And it has stored it as y1. So I'm going to copy down the equation here. Okay, so the equation is y equals, and we can round, 0.034x plus 5.67 for these. I don't need you today. You can have the day off. You're free. Yeah. Thank you. Okay, so that's our regression equation. And then we want to go and graph it. So we'll go up to y equals. Okay. Oh, and look, there it is. So they have stored it for us in y equals. And I want to do a scatter plot as well as graph the equation. So to get the scatter plot, I want to go up to plot 1 and hit enter. And now it has turned it on. If you want to double check that it's the right variables, just hit second y equals. And that'll get you there to make sure that plot 1 is with graphs L1 and L2, or with the variables L1 and L2, okay, those lists. So then, again, I'm back at my y equals. I've got my stat plot on, and I've got my graph. So now I want to actually graph this. However, I think my window is probably going to be off. and sure enough, it is a little strange. Okay, so I want to graph this for the data that I was given. So let's go to our window. And my x values are going from 320 to 1200. So let's start our x's. We can start at 0. But then we'll go up to about, let's get up to 1500. And let's go by hundreds. The y scale, again, I'll start with 0, but I only need to get up to, 50. Let's get up to 70. And we can go by tens there. Okay, that looks better. So now what we've done, and I'm hoping you can see this okay, is we've scattered those 4 plots and we've graphed the line of linear regression, or otherwise known as the line of best fit. And as you can tell, this line is best fit. It's right down the middle, sort of the average of all of those points. Okay. Part B says, the regression line gives a functional relationship between per capita cigarette consumption and lung cancer deaths. Use this relationship to obtain estimates for mortality rates in 1950 in Denmark and Norway, given that the 1930 consumption figures for Denmark and Norway were 373 and 257 respectively. Okay, so what we want to figure out, let's start with Denmark, that it was 373 was the x value, and we want to figure out its y value. Okay. And then the Norway one as well, it was 257, and we want to figure out its y value. So what we can do now that we have our graph in here is we can just go to the table and we can just type that number in, 373. And there it is, 18.43, and 257, 14.461. So those are the estimates for those two countries in those years, okay? So estimated that in Denmark it was 18.43 and in Norway it was 14.461. And again, we just used our calculations here. Part C, compute the percentage error in each estimate, given that the actual death rates were 18.4 and 9.2. Okay, so this was our estimate. And if we compare it, the actuals were 18.4 for Denmark, and the actual was 9.2 for Norway. Okay, so the Denmark one was very close on, but the Norway one was not very close. So let's actually calculate that percentage error. Again, we're using the equation from the graph before, or from the page before. Actual minus predicted over actual times 100. So let's start with Denmark. Absolute value of the actual minus the predicted over the actual times 100. So I would get 0.16, I believe, percent error for Denmark. That's not bad. How about for Norway? Again, actual minus predicted over actual, 9.2, sorry, times 100. And when you work this one out, type that all into your calculator, work it out, that's a 57.18% error. That's huge. So this model was not good for Norway, obviously, but it was very right on for Denmark. Okay. The last question here says, assume for a certain Scandinavian country that the number of lung cancer deaths in 1950 was 46. Use the relationship from the data above. Using the relationship from the data above, what would be the corresponding cigarette consumption? So what have they given us? Instead of giving us the X value, they have given us the Y value. Okay? So the way you can do this are now the directions on the page before, but it's that second table. So it's when I've got given the Y value and I'm trying to solve for the X value now. So this part is what I'm going to use. So let's go through these steps. Y1 is still our regression. Y2, they want us to type in the given Y value. Well, what was the given Y value? 46. 46. And then what I want to do is go to Graph, and I already have the viewing window. But what have I done? I've typed in that other Y value of 46, and what do I want to figure out? I want the intersection of those two, right? So I'm going to go to Second, Calc, Intersect, and and I'm going to get over toward that intersection point. Perfect. And again, and again. And there's our intersection. You can see it at the bottom there. And so the x value was 1178.94. Now, does that make sense that it's about 1178? This is people, or no, cigarette consumption per person. So we could round that up, 1179. Now, would that make sense if the y value was about 46? Well, let's look up at our table of values. If the y value was in here somewhere at 46, does it make sense that our x value would be at about 1179? Yeah, it sure does, right? So if we knew that there were 46 deaths per 100,000 meals, they should have consumed about 1,179 cigarettes per person would be our estimate. And we would have to look at the actual data then to see the percentage error. That's it. Go do your homework.